let's start. So welcome everyone here. Thanks to the speakers who attended and for their collaboration to making this workshop a realization. So the title of the workshop today is Control Plus Rebuild, Supporting Circular Construction Through Data-Driven Solutions. In terms of the content of the workshop, this is actually a series of talks about five different projects, mainly DATAWiSE, Wilson, INBLANC, RECONMATIC, and Decode2. DATAWiSE, Wilson, and INBLANC are sister projects. That means that they are funded from the same horizon call. And we have also identified RECONMATIC and Decode2 as potential collaborators because their themes were very relevant to what we aim to do as a consortium of projects. So here we have the agenda. The structure is 15 minutes per project. So we'll start with DATAWiSE project right after the introduction. We'll move on to Wilson, then INBLANC. Then RECONMATIC, Decode2, and finally we'll have some time for a Q&A with online participants and with the people that are present here. In terms of what you'll see for each project is a brief introduction, so you won't get a deep dive into each project's scope and so on. But hopefully you'll get a good idea of what they are about, and all people that are representatives for each project are present here, so you might want to either redirect yourself to the web pages of each project, or you can come and talk to us about possible collaborations or things that you're interested in, and so on. So you'll get an introduction about each project, the state that they're in currently, and what the future holds for the next year or years, depending on the duration of the projects. So without further ado, I will move on with the first project. So I'm Jens Karvelas. I'm from Scientific Project Manager in Singular Logic in Athens, Greece. So in terms of our role in DATAWiSE, we have been involved in work package leaders. Also, we are developing some solutions for the project, and we are also involved in the dissemination communication part of the DATAWiSE project. So a few words about this. When we are talking about DATAWiSE, the full title of the project is Intelligent and Sustainable Building Management, powered by cross-sectoral lifecycle data. Some general information about it. The consortium consists of 16 partners from 7 different European countries. It started last June, so June 2024. The project duration is 39 months, so the end of DATAWiSE will be somewhere in the 2027. The coordinator is the Center of Research and Technology, Hellas. And this is part of the innovation action funded by CENIA, by the European Union. I'm going to be very brief and to the point of what DATAWiSE is about. So first of all, we are talking about a collection and fusion of different data that revolve around the building life cycle from multiple different sources. So we're talking about a decentralized system that collects data from different regions and partners. When we're talking about data in DATAWiSE, we're talking about sensor information. This could be related to HVAC systems, air conditioning, people detection inside buildings, energy storage, sensors, and so on. Also, we are focused on BIM data, so building information modeling data, in order to support the generation of digital twins. Meteorological data, these relate to some services that involve, floods or extreme temperatures and so on. And we also have other systems. So after the collection of these and fusion of these data, we are working on the development of 2 different groups of services. So first, we have the development of services that target energy efficiency and holistic management in buildings. and the development and testing of intelligent building management tools, so energy efficiency and building management on the other hand. These services, I think there are 4 in each group, so these will be integrated into 2 different toolkits that will be available to the end user. After the development, we have testing and evaluation phases in DATAWiSE for all the solutions in 3 different large pilots that I will explain later. As part of the project, we also aim to provide a deeper understanding of the whole building and renovation operation process. And hopefully, with the results that we have, we will target a fruitful dissemination and business plan for future exploitation. Here I have listed the 2 different toolkits, the 2 different groups of services that I was talking about earlier. One toolkit is called the Data-Driven Building Performance Management, DBPM. Here we have services related to electrical and thermal flexibility management, generation demand forecasting and optimization, this is about energy, adaptive building risk and resilience assessment, and smart sustainability and comfort balancing. On the other hand, we have the lifecycle data-driven decision support, LD2S, which features predictive maintenance, integrated sustainability performance management, circular lifecycle assessment, and smart readiness assessment. Actually, in this event, Sustainable Places, there are multiple sessions about smart readiness, so it's something that you might have heard so far. In terms of pilot sites, we are involved in 3. We have Riga in Latvia, Stans Murstal in Austria, and Madrid, Spain. In Latvia, we focus on 3 educational buildings that are built during the 70s and 80s. They have been renovated, but they are very high in demand in energy consumption. In the university, in the second pilot in Spain, we have a university, I think it's University Isabel I, and there is also an adjacent hotel and sports center that they aim to provide data-driven tools to the managers in order to optimize energy usage. And finally, we have an energy community in Austria that is very focused on energy independence and green energies, and they think that they can benefit from the development of the services that we are having in DATAWiSE. In terms of where we are with the progress, so right now we are in month 17. We started, as I said, in June 24. The first 11 months were dedicated to, as we call, phase 1. So we had co-creation activities, solution design and development. These were more, these activities revolved around the general direction of the project. So as internal milestones, I've listed multiple things here. We had the general vision direction of the project, the identification of key performance indicators. A very important task was the design and conceptualization of the platform architecture that will serve as a backend for the services, the infrastructure of the toolkits. Also, a great deal of effort was revolved around the user requirements, the use cases that were also later translated into technical requirements. And also there were some preparation activities for the data collection from the pilots. Right now we are in phase 2. And so far, we are aiming next month to have a first version of the different services that are being developed. A backend prototype in order to support the data flow from the pilots to the services. There are some preparation activities regarding to the pilots and an analysis of the assets and the services. In terms of what the future holds, in 2025, we are continuing with phase 2. So we are focusing on the development of the prototype version of the platform backend and experimentation of the service providers with open data and some provisional data from the pilots. And finally, we're working towards the integration of the services into the DBPM and LD2S toolkits. In 2026, we are concluding phase 2 and we're going into phase 3. So we are talking about the progress in the services development and testing on the different types of data, integration of these solutions on the pilot sites, and continue with iterative testing on the use cases that were developed in phase 1. Finally, we conclude with 2017 phases 3 and 4, which will have the refinement of the deployment of the solutions. There will be improvements in the services backend and backend of the platform. And also the final is the upscaling and the work around the application of the solutions. So I don't want to spend any more time on this. Thank you. We can talk later if you want. And I'm moving on to the next project, Wilson. So Andreas, the floor is yours.
So, good morning, everyone. So I'm Andreas Muñoz. I work in CSS. CSS is a research center in Spain, in Zaragoza. We focus on solution in energy environment. And I'm also the coordinator of this project of Wilson. So let's start with some big numbers. Wilson started at the same time as DATAWiSE. We are from the same call of the operation framework. This project will last 4 years, also 16 partners and 4 different pilots and 1 living lab for testing our solutions. Okay, so what's the main objective of our project? The main objective is to obtain and to enable more efficient data in the building environment. Not only the lack of data is not only a problem in the building environment, but also in different environments. But I'm sure that all the tool developers that we are here, we know that having data with enough quality and quantities is very difficult for testing the new solutions. And we think that this is very important to start moving on more advanced solutions. For that, we are developing a data layer, okay, for data management based on data spaces, okay. That I'm sure that a lot of you have heard about that. Where all the information will be connected in a harmonized way, information about BMS, digital twins, or whatever source data we have. And on top of that, we are going to develop some tools, not only focused on energy, but in non-energy applications to be tested in the demo sites. With this image, I want to share the general view of the project. We have in the middle a federated data mesh that will be this data space, okay, where all these BMS, we have 9 innovations in the project. One of them is a digital twin, not only focused in the building, but also in a district level, okay? The idea is to get a higher level of digital twins included here. How we are going to obtain this information. We want to integrate it in a harmonious way using interfaces focused based on ontologies and AFC classes that we call here personalized data hubs. And also we have a peer-to-peer marketplace because the idea is to give value to the data, okay? The data owner could share the information for a tool developer, for example, if someone needs information to test some predictive maintenance algorithm or whatever, and they don't have information about some building, the idea is that an owner of the building connected to this data space to this marketplace could share the access to information for some time. On top of this data layer, we have 6 different innovations focusing on different areas that I will go in a little bit in detail later. About the demo site, we have 4 demo sites and also a living lab in our facilities in Circe, okay? The idea is to integrate all the solutions previously in our living lab before going to the demo sites. These 4 demo sites will be focusing on different use cases, okay, and are in a different states of the life cycle of the buildings. So far, what have been done in this 1 year and a half? We focus in the data space because we think is the basis to start integrating the tools. It's International Data Space Association is one of the partners of the project. Okay, they're providing their solution, their architecture model. They are pushing in Europe as GaiaX, for example, to develop these data spaces, especially focusing in different areas. For example, for mobility or for buildings, in different areas. We think data spaces are important because it's a decentralized solution that is also very scalable, providing interoperability, governance of the data, and so on. So we think that it will be interesting in the next years, and I think we are going to see more projects with these solutions. Also, in this first year, as in the case of DATAWiSE, defining the demo site and the use cases is very important because it is the basis for the technical requirements for the tools, and also takes a lot of time in most of the projects. Or 4 demo sites we have in Spain. We have in Barcelona hospital, okay, where we are going to test a solution for energy optimization, okay, taking into account all the consumption energy of the hospital. That is one of the main important issues for a hospital, and also an investment planning tool that will help for the renovations to know how much money do you need for the investors and how to obtain these investors. In Switzerland, we have a rural area where we have a DSO in our project that provides energy for the whole area. So the idea is to test tools for the network operators to improve the efficiency of the management of the network, and also to boost the green energy investment, okay, to improve the photovoltaic and so on. In Newcastle, we have a whole district of buildings, 7 different buildings. Some of them are public, like part of the University of Newcastle. Some of them are private. And the idea is that having this district and focusing on the digital twins at district level, we also have a lot of information from different sources, different owners, that will be a challenge to integrate all of them inside the data space. This is the use case we want to test, apart from a predictive maintenance tool. And finally, in Bergamo, in Italy, we have an old military base that the city council is renewing. They are renovating some buildings, they are constructing new ones. Is a demo site in a different phase of the cycle life of a building. So the idea is to test solutions for renovating planning and design. So the architecture, how we connect all this information, I'm not going to go very deep, but the idea is that we have information from very varied sources, sensors, user information, maintenance, the BIM information, of course, environmental, financial. We have to provide some interface to connect to the data space. Depending on the source, you are going to need some pre-treatment, okay, of the information to change the format. But the idea is that all this information will be with the same format, let's say, in the data space components, and the tool developers, service providers, third-party solutions or external business application could connect to this data space and obtain this information and provide their output, okay? For example, a tool developer inside the project could access the information for the inputs and provide their output if anyone needs a predictive maintenance estimation, for example. About the tools, we are starting the first version of the tools. We have these 6 are more technical, and we have one more that is focused in the financial area. For the building management, I assure that in this meeting, in other workshops, you have heard about something similar. We have an energy management solution, also a predictive maintenance one for the building management. In the environmental performance, we have a biodiversity tool that not only calculates the lifecycle assessment, but also the cost-benefit analysis and several indicators about the integration of the urban area with the environment. A material passport tool that provides, let's say, a database of the material of the building, but also that will be periodically updated. The idea is that accessing this data in real time, let's say, could provide an updated version of all these solutions. The same happens with the risk and resilience. You calculate the risk and resilience at the beginning of the project, But at some point, you can take into account that the buildings get old, and which increases the risk, but the renovations also affect the risk and resilience. With this updated in real time, you can have these calculations updated. And also a smart readiness indicator using the information from the building. And finally, the investment planning tool, I talked before about that, is taking information about the financial data of the building. We can calculate the investment needed in the future and try to find investors for these renovations. So to sum up, the idea is to provide a common data layer to access in a harmonious way the information from different demo sites that will be extended to other buildings, and to develop on top of that different tools. Right now, we have the first version of the solution with the data space being tested and the living lab as the first testing phase. Next year, we want to finish all the developments and to start thinking about the demo sites and the integration phase in the 4 demo sites. And finally, for the 2027, we want to focus on the demonstration phase to analyze the results of the demo sites, to improve the solutions, and finally to try to interoperate with different projects, platform, data spaces to test that this idea of having data spaces connected with each other will help the European environment to develop new tools. So that's it. Thank you. And I leave the floor to
Fatima.
Fatima.
INBLANC.
Hi, I'm Fatima Ascarzada from Demo Consultants, and I am here to present INBLANC for today. So INBLANC stands for the Industrialization of Building Lifecycle Data Accumulation, Numeracy, and Capitalization. It's an innovation actions type of call, and we have started this year in January, and we are running for 3.5 years. As demo, we are coordinating the project, but as a partner, we are also mainly contributing to the project by developing the platform and digital building logbook and BIM-based services. And together with our 21 other partners, we make the consortium of 22 partners, including different types of organizations from different countries. So, but around the project, first of all, I see, of course, lots of mutual, I think, aspects and similarities as the cluster has been made. But our starting point as a problem is actually the low rate of renovation and also the poor performance of the buildings, which contribute to the big role of construction sector in CO2 emissions and energy consumption. And as a solution, INBLANC is proposing an open ecosystem where the data is leveraged from the whole building life cycle of buildings and provides input for the whole life cycle and for the whole stakeholders involved. So here, in this scheme, I want to show you the main and essential core of the idea and concept of INBLANC. So here you can see a few layers. In the middle, we have the digital building logbook, and also we see the different stages of the life cycle of a building. So in the core, we are about the accumulation of the data from different sources that we have. And we see the digital building logbook as the pivotal point and as the core of the whole data accumulation of building, where we have these different indicators and catalogs of indicators that I will explain later on, where we are transforming the data to the information, as you can see. And then from the information, we go to knowledge or actionable insight, where we have different services and tool sets for our stakeholders. So in a nutshell, here we see how the main concept of the project is to going from data to information and to knowledge, or from data to insight and to value for the users. But looking at it from a different point of view, and if you remember the name of the project, we had accumulation, numeracy, and capitalization. So here we are looking into these layers of the INBLANC solution. So as our core, we have the accumulation. The goal here is to have a smarter data collection. We have multiple and diverse sources of data for buildings. And also it's important that we cover the whole life cycle of buildings, so from multiple and different stages. Our second layer would be the numeracy, where this data that we have is going to become transfer to insight. So in the numeracy layer, we have indicators or key performance indicators that are being calculated from this data that has been collected, and then from there we have the capitalization layer, where these indicators are being fed to our tool sets and to our models that can provide informed decision making for the users. This all happens in our ecosystem, and then the ecosystem is the main solution of INBLANC, which is accessible to the users. So talking about the users, in the bottom here, you can see the 6 target groups that has been defined for the project, from owners and managers of the building towards research committees or architecture, engineering, construction sector. But here I want to explain a bit about the numeracy layer of what we have. So here you see that the data management platform. In the data management platform, we collect the data, we do some calculations and some optimization on the indicators that have been calculated, and then we provide different tool sets to the user, which all happen in this platform. So a user can have access to multiple tool sets environments. But here you can see 5 different categories that we call them indicator catalog. So we have 5 categories in our indicator catalog. The indicators in each of these categories are defined based on the user's needs that we have identified, based on the tools and services that we are providing. And at the end, this catalog can be seen as the instructions of how the data should be evolved to the information. So having these indicators, we have also a Nexus strategy and Nexus toolset, where the interrelations and overlapping of these indicators are being mapped. So then what is provided to our toolsets and to our models are optimized in terms of the indicators that they can use. We are also, of course, having the interoperability with European level frameworks such as SRI levels. We are also providing some of our data sets via data space connectors as well. And also we connect to some of the external databases based on also data space. So in a nutshell, how this platform or what this platform looks like is that the user has access to this platform with a global authentication that then when it's done, the user can access multiple environments from different tools. There are dashboards providing the results and performance of the buildings of the users. And there are, of course, the repository and the digital building logbook, where multiple sources of data are connected to it for the platform. And then on the right side, you see that we have, it might be a bit small, but you see that we have 5 services defined here. So energy management service, BIM-based service, comfort and economy, renovation support, and space as a service. These are our 5 main services. For each of them, we have multiple tools. And then we have also the Nexus toolset, which, as I mentioned, provides insight and provides optimization for the indicator catalog. Now looking at the DBL, as we see it as the core of this whole project, I think the digital building logbook is also a common and trendy, I think, aspect of lots of projects now. The digital building logbook has some guidelines and has some like defined definitions. However, how we define it in the project is also, I think, a core aspect of INBLANC. So Besides the guidelines that are defined that include specific information about the building, how we see the DBL is not only as a repository of building data, but we see it as a whole life cycle repository of building data, which does not store all the data, but it is about the correct linkage and correct connection of the data and also integration of them. So it means that not all the data is being stored on the DBL, but the required data is linked through the DBL to the sources and then also provided to the different components that we have in our platform. I think also similar to the previous projects that were presented, we have also 6 pilot buildings or pilots that are going to be used in the later phase of the project for demonstration and validation. We have a diverse portfolio of buildings. We have buildings, building complexes, but also neighborhoods and urban scale. So we have, for instance, the city of Aalborg as one of our pilots. The interesting thing here is that we are not having the similar validation for all of the partners. Each of the pilots have defined operational scenarios, meaning that our tool sets and services are not going to be demonstrated in all of them. So each of the pilots have their own story and have their own unique way of demonstration. And of course, they target different users and of course different goals for each of them. From residential to non-residential and from small scopes to larger scales. If I want to show you how the project is planned and where we are standing, so as you see, we are now in the design phase. We have just entered the 10th of the project. We are defining the project in these 3 phases: design, development, and deployment. We are now in a very crucial 3 months of the project because we are now finalizing our design in terms of data architecture, but at the same time, we are just started with the development of our platform and the tool sets. So in these 3 months, we have this overlap that we can utilize as much as possible to connect the design and development. And then in the latest phase, we have, of course, the demonstration and the validation. So connected to that, for the next or for the future steps of the project, by end of 2025, we are going to finalize our data management architecture. We have already our data, our indicator catalog, a very comprehensive indicator catalog from which a selection is made that is the core of our numeracy layer, meaning that indicators are selected that are calculated automatically based on the definition of them, which are fed to the tool sets and to the services. And we, on the engagement and acceptance part, we are also having and finalizing our strategy. For the next year, the data accumulation from these pilots start. So there are some pilots that sensors are already installed, so the data accumulation will start. We also, of course, use the historical data from some of the pilots. We will have the platform and the DBL developed for the project. We are going to integrate the developed toolsets and services into the platform. And we also have the solution acceptance in the value chain of our target groups. And for finalizing and towards the end of the project, we start with the operational demonstration. So all the solution and all the components are being demonstrated and validated. And of course, we have the exploitation and uptake and finalization of the project. So as you see, we are still in the first year and in the, let's say, beginning phase of the project. But we will be very happy if you would like to follow our progress. We are available on X, LinkedIn, and our website. And of course, I will be happy to have any questions at the end of this session. Thanks.
Okay, so next in line is Jens and Wanda for a very dramatic project.
Thank you. So this name has changed a little bit because Jan Valentin, the coordinator of the product, coordinator of the project, couldn't come today. So I'm substituting him when talking about RECONMATIC. The project is here like for 3 years already, and we will finish next year in middle of 2026. Czech Technical University is the coordinator of this project, and we gather plenty of participants from all around Europe, and we focus on developing of the technologies which I am going to talk about and demonstrating them. So very similar concepts to the projects that we already discussed here. Well, there was some basic idea how to increase the sustainability of construction sector. First, we wanted to focus on architects, engineers when planning the building, incorporating their developing tools that can help to increase the efficiency of the structures and limit waste production. Once we got this, we also wanted to focus on the next stages. This is very crucial for RECONMATIC. We develop solutions that allow to map the existing buildings and plan the reconstruction, or as we call it, deconstruction, which means the same like demolition, but in a clever way. And once we have the building down, if it's not possible to renovate, we are also developing solutions how to use the materials from after the demolition in most efficient way, and how to sort this. Here you can see the overview of the partners involved and the demonstration cases, which I'm going to talk about in a few minutes. So here is one of our contributions to the sector. You talk about using IFC or standardized data for your platforms. We found that IFC is not complete in regarding the sustainability parameters. If you want to include sustainability parameters in the building, in the design, IFC is lacking crucial parameters, and that's why WASE database structured as IFC has been developed, and this can be imported to ArchiCAD, Revit, or own software solutions, and worked with in the same structured way as with IFC. This was developed with the vision to use this for pre-demolition audits, which means like auditing the materials used for recycling after the demolition, but also to optimize the structure, to optimize the maintenance of the buildings. Once having these parameters, our UK partners were able to create a tool called Waste Predictor. This tool is used in the design phase. So when they are designing a structure, they have this kind of predictor based on historical data. There is some machine learning model behind this, which predicts what will be the impact of the construction, but also the whole life cycle of a structure on the environment. That was very similar to the platforms that have already been discussed here. Central system called DIMS, Digital Information Management System. I'm not involved in this, so I'm not going to talk about this application too much, but generally the idea is very similar to what has already been discussed here. You have some data on the peripheries and collect them into one single system that allows through some platform, some interface inform the users, construction managers, engineers about the state. Well, this is just well, the idea how to what is the integration of the data. And now I want to talk about the demonstration cases. Well, these are separate demonstrated technologies that we use around Europe to show how modern IT technologies can be used and implemented in real life scenarios. This one is from Greece, where the concrete production plants, concrete is a huge contributor to CO2 emissions, etc. But concrete is always wasted, because if you send a truck to the site, you don't want to send less material than it's needed. So there is always some 10% of the material left, and it's usually brought back, and the concrete production plants have to dispose of this material, which is wasting quite useful resource. So there is actually now an operational platform based on blockchain, which serves for delivery of the material, and it allows different clients and different factories communicate, and you can reserve if you need some amount of the material, something that would be wasted otherwise. It is something like Uber for concrete. You see what's happening everywhere in the neighborhood, and you can use something that wouldn't be used otherwise. This was one of the technologies. These demonstration cases are kind of separate, so I will talk about another one which is rather different. We demonstrated on a real building that was, it has already been demolished, that we can dismantle the building in a very efficient way, use the materials as much as is legally possible. This is a problem. Sometimes the technologies are ahead of legal restrictions. You can't use materials that could be used, so you have to balance on this. And doing those pre-demolition audits has been quite demanding and costly for construction companies. That's why construction companies try to avoid these. The first bottleneck is to get a model of the building. It is usually non-existent, and that's why we developed our software that takes in the point cloud from laser scan and reconstruct the building element-wise. So instead of unstructured data in point cloud is transferred automatically to something that is readable for the machines, which is IFC model of a building. And once we have IFC model of a building, those figures are very small, but you can see waste E to IFC. This is the next step. So when we have this IFC model of a structure, this is just geometry. You can't extract more from the point cloud, maybe the materials, but this is not actually the case now. So once we have the model, we can go to the building and use our next application, which is a web application available. You have your model, you walk through the building, and you can fill in the information to the individual elements about the state of the building. So you say like, hey, this wall is made of bricks and it's contaminated. This is what waste parameters are about. And we integrate this into the model. And then you can view the data in any software that has the waste integrated. And you can integrate it to ArchiCAD, to Revit, to any kind of software engineers use these days. So actually, we sped up the process from months to days. And this is just a visualization. Once you have the data collected, our colleagues in Spain developed an application that can process all the data and create automatically this pre-demolition audit and statistics about the building. So just take this as the output from the measurement as an input to this application, and you get all the data needed. This application is still under development, and we just discussed what should be the output of this application. Well, once the building is demolished. There are some leftovers that cannot be used directly in the other building, usually crushed into pile of debris that is brought to the sorting yard, where they are able to take the rebars, reinforcement, which is magnetic, and light stuff that can be blown away. But you are left with the debris consisting of gypsum, concrete, mortar, bricks, and these have very similar mechanical properties, very similar density, very similar shape, and this is hard to sort. And that's why this material is very often downcycled, put to some such as a sub base or something like that. But the value of some of the pieces is very high, especially these days. For instance, in Czech Republic, we have problem with quarries. We finally built some new highways, and there are not enough quarries in the surrounding areas. So there was a big demand for recycled aggregates. But it is very difficult to extract recycled aggregates from this pile of debris. And that's why we developed a computer vision-based system that can identify, and robotic system that can extract the individual pieces. Now we are like at 80% of this development. We have the algorithms, we have prototype of a robotic arm, but we are currently working on a different way how to sort the waste, because robots are very delicate stuff. And the amount of waste flowing in the sorting yard is very fast, and you need some system that can very quickly separate those valuable fragments. So we are thinking about using air jets that can blow away the particles in the fall, which we want to separate. And finally, when I talked about Uber, this is another application when we got inspired by Uber. This is when we collect waste. Collection of waste in Central Europe is such usually for small stakeholders, but even for bigger ones. You order a container, you fill it, and you send it back to the sorting center. The thing is that the transportation is not always optimized, and the sorting centers have no idea what is at the bottom. So the pricing of this service is difficult, and then the consequent sorting is very difficult. And that's why we developed IoT system. Maybe it's on the next slide. No, sorry. An IoT sensor that is very heavy duty and is placed on the container, takes images of what's going on, collects GPS coordinates, and sends it, which sounds like an easy job, but it's not, because those containers, those skip bins are placed in a harsh environment, construction sites, very dusty, Central Europe, freezing, hot, cold, rain. So these units that we have developed, unfortunately, they are not in the presentation, are attached to the container, and very carefully designed for extended battery life, because you can't charge these. This is not feasible for the providers. So there is like a very small solar panel, which must be enough. And that's why we are not sending the data, like the full package of data, like every second, minute, hour, but only when something happens in the container. So we have sensors that wake the IoT unit up, and if something has changed, it sends the data. And that's why we implemented AI model that we developed on synthetic data and then tested on the real data in the unit. So when the unit recognizes there is a new material in the container, I send the data. So this is another Uber for waste kind of application that we use. So in RECONMATIC, we developed several technologies that are not, they have no joint component, but can be used for different stages of construction or demolition or sorting of waste. So thank you.
Okay, so my name is Yannis and I will talk a bit more about RECONMATIC, around 5 minutes, not to diverge from the topic of the session. I'm going to talk about clustering activity that we are going. So it's, let's say, innovation of RECONMATIC, and we have developed this circular construction cluster. If you scan this QR code, you will be able to go to the webpage and register it yourself. If you were in yesterday's sessions, they stretched out the idea that clustering is super important. That's why they had 4 clusters presenting from the Build for People initiative. So our aim with this is to also get it involved with the Build for People initiative. And I know that there are some calls as well, post-action calls, that are funding clustering work. So it's a pretty big opportunity, and one that has not been happening in Horizon 2020, for example. So these are our members. What's worth noting here is we don't have only Horizon projects, but we have, for example, the Latin American Alliance for Circular Construction. So we have public or private entities, and we have EU projects as well. So you will be able to join from whichever avenue you are more suited to. So let's see some previous activities that we have done and skip and focus more on the ongoing ones. So we have collaborated with the Circularity project in finalizing some KPIs. For RECONMATIC, as Vaclav presented, we have another tool that assesses how sustainable and circular are your processes, even if you're an architect, if you're a building manager. So this assessment is based on KPIs. The cluster helped us finalize those KPIs through, let's say, peer review methodology. So they tested all the KPIs, they said, okay, this is not good for water management, this is bad for CO2 management, etc. So we have collaborated on this, and this is finalized. And of course, we collaborated on the waste data dictionary that Vaclav was presenting before. So there we finalized, we came to a conclusion on the attributes of all the materials that are going to be recycled or hopefully reused that was presented beforehand. So some current synergies is that we are building a glossary of types. This is like a construction wiki. So you go in there, you will be able to edit as well, such as the wiki page. And you will be able to find any term that you might need in a construction project, in the design phase, in development phase, end of life, whatever. So this is under development. We have many ideas on how to present this. It could be through a chatbot AI, through a wiki page itself, through a different website. We are through a storytelling maybe scenario. So this is a very good opportunity, and we have had some people that will chime in from the circular construction cluster. And the most important thing I would say is the training materials. So for RECONMATIC, we have developed training materials, 9 lectures, for all the things that Vaclav and I have talked about today. These are going to be free. These are going to be on a platform that is going to outlast the project, of course. So it will be maybe 10 years after. So we have no plans of taking it down. So everyone will be able to go and train through this. Now, we have the cluster because we see many projects have training materials as well. So in that way, we plan to collaborate, maybe promote the training material of the other projects as well, or maybe have workshops together if we have similar lectures, or maybe see that, okay, the digital twin of a building or a BIM modeling is taught differently by other projects. What can we do about it? Can we standardize the way that we are teaching this thing so everyone can understand it in the same way? So this is a current activity, and we're under discussion with many partners of the cluster for this, and even more partners if are joining in the future. And the last thing that we're currently doing is we have identified that we have many Spanish-speaking partners. So we are brainstorming right now on what to do for the Spanish-speaking partners. We might do, let's say, a social media campaign just in Spanish, or maybe a dedicated web page on the RECONMATIC website for just Spanish-speaking people, or some workshops in Latin America, which I know there is high demand for this kind of projects. You know, the European construction sector is, I think, some has had more time to adapt than the Latin America construction sector. So we see a great demand on workshops, on educational material, or events and stuff from the Latin American partners that we have. And this is pretty much it. So if you want, you can contact me or my colleague Chris, or reverse scan this QR code. This is how you get to us about the cluster. And of course, I will talk about, or even if you read the brochure in front of you, you can contact us whenever. And let me talk about the future plans of RECONMATIC. And of course, if Václav has to add something, he will add later. So as I told you, just so you know, we are finishing in June 2026. So most of the things are going to be done 2025 and 2026. So we are finalizing the web-based platform that is going to have all the lectures that I told you about. There is currently one small step, and the platform will be online. So this will be done in the next months, I would believe. Then we have an international workshop. What for? The international workshop will be organized by the consortium and the circular construction cluster members, and we're going to present the circularity assessment tool that I talked about before, the KPIs we identified. These are going to be used in the circularity tool. Then we're going to demo the tool in the workshop. This is going to be like people testing hands-on this tool and saying to us, okay, this doesn't help, this helps, please do this better. So there's going to be a campaign for that as well. You can join, even if you are an economist like me and have no building construction plans. Okay, it's normal. And of course, the glossary that I talked to you about, we're going to finish it and publish it in any way possible. So the more interesting things are happening in 2026. We're going to have the final conference of the project. This is foreseen to be done in May because June is the last month of RECONMATIC. So we are currently discussing if it's going to be hybrid event, online event, or collaborating with other conferences or other projects, or to do an event altogether. The other thing is that we have 2 more open days in China. So we have Chinese partners in RECONMATIC, and we will do 2 events showcasing the demos there and how valuable our solutions are in China as well. Then, of course, it's the usual exploitation activities of the project that since we're drawing to the end of the project, these are taking up more and more focus time, building how to use the results after the project, building spin-offs, having them open source, this kind of thing. And of course, the Spanish initiative of the CCC cluster. And then for 2027, after the end of the project, I propose as exploitation leader, as innovation manager of the project, to all the results that will not be used primarily and strictly through partner use are going to be uploaded in the Horizon Results platform. It's a good tool for stakeholders to find solutions and for solutions to be matched with stakeholders. Many projects have it in the grant agreement that they need to upload the results in the Horizon Results platform, and at least 1 year after the project. So it's a good one. And of course, try to get new funding. I told you about some goals that are cluster-based, but some other calls as well are not. So, and of course, the market entry of specific results. As I told you, hopefully some of them will be proprietary and will be used by the organization themselves in joint activities, maybe create a spin-off, maybe sell it as a service. So these are the plans. And I don't know if I have to add anything or I covered it.
Yeah, actually, I just wanted to To clarify with the spin-offs, this is something we are just already testing in the Czech Republic with the software that is used for transformation of point clouds to IFC models. So for us, this is the first experience with such kind of commercialization. So we will see how well it goes.
Thank you very much. Thank you very much for your talk. Okay, next up we have Decode 2, and we welcome Anastasios and Eleni to the floor.
Hello, everyone. This is Eleni Kolova from DATAWiSE Greece. We're going to talk today about Decode 2, our project about dynamic decarbonization pathways framework, which is integrating technological, social, and policy innovations for sustainable renovations in the built environment. So, what actually Decode 2 stands for? Decode 2 is a project comprising 17 partners across Europe from 8 different EU countries, spanning around 48 months of integration of new technologies. And it is being deployed in 3 living labs, which I'm going to discuss more in a few moments. And we have had 7 million euro funding from the European Union. So I would urge you to scan our QR code and have a look on our website and follow us in our social media. So let's talk a little bit about the vision of Decode. Decode 2 is spanning around 3 pillars, one of which is the technological one. The technological pillar is the one that is data-centric and data-oriented. However, the idea of making data useful is mostly based on the other 2 pillars, the social innovation pillar and the policy innovation pillar. The 3 pillars are complementary and are focusing in order to provide a decarbonization pathway towards renovation activities, building upon technological innovations and regulatory changes, which are necessary in order to make data meaningful. So in our project, based on our 3 living labs, we have been setting 3 different value chains of actors, of approaches, and of materials. So our first value chain set in Ireland is focusing on bio-based material and prefabrication. So it is quite unusual to have mycelium as a raw material to create insulation. So people would need to know more about this and accept it. How do people accept these sort of innovations, and how do professionals accept? So this is where policy comes in, and this is where the digital approach of the worth of the material itself provides insights to architects and designers to introduce new cutting-edge materials into their design choices. So this is where data is being used in our first value chain in Ireland. The second value chain is a very interesting industrial symbiosis ecosystem set up between Valencia, the municipality of Valencia and of Castelló, and the UPV in Valencia, where we have a full end-to-end cycle from waste to actual implementation. So what do we have there? We have a municipal library being taken down for renovation, and the material from this library is being tracked, is being monitored, it is being sorted, and is going to be reused on a new living lab, a regulatory sandbox, which will provide the space for testing and accepting and monitoring circular materials on a campus building that is going to be set in UBV. And this material is going to be not only monitored in a digital way, but it's going to be simulated via digital twins. It is going to be sorted and scanned via LIDAR technologies, and it's going to be even constructed using robotic construction. So we have a full life cycle across the entire value chain of industrial actors there, also monitoring local value chains of materials that are being tracked from the demolition to the reconstruction. So we're going to have a full monitoring of this entire process. Our third value chain approach is community-oriented. So the question here is what data can do for the people and how are people embracing this digitalization into their everyday life. We have the chance to engage a very important building, the Terrassen House in Graz, Austria, which offers also the strength of people living all together and deciding for their own living conditions within their building complex. And they get to co-decide, they get to co-design, and they get to learn on a first-hand basis about the technologies that may make their lives better and their renovation choices on an entire level, on a communal level, better in the future. So data actually here becomes an actual contact point among the people who will use this data to decide. So to summarize what we have here in terms of target groups. In the first value chain, we are focusing on the professionals. So how are the professionals more accepting our approaches better? And of course, how do they engage with learning about the new materials that are available across the innovative circular approaches? How do we accept materials that have been used on another building, or materials that are innovative, such as mycelium? How do we integrate them into our design choices? And how do we get the skills to design appropriately using new technologies? The second value chain is focusing on the entire market ecosystem from end to end, from the demolishing actors to the actual architects, the designers who will be making the choices to bring them to the next level. And then the actual end users who will evaluate the outcome of this end-to-end approach. And the third one, which is one of the most important approaches, is the final end user, the inhabitants of the building, the building owners, the building tenants, the ones that have a first-hand contact with the materials and the choices of professionals. So this is DECO in a nutshell, making data meaningful and integrating technological, social, and policy innovations into meaningful decision-making for circular renovation. So these are our data-driven solutions. So we are engaging with material passports and traceability solutions, BIM-based building digital twins, which I think were a prevalent technology across all our projects today. We have a local value chain mapping, which is really important on a regional level. because circularity does not happen in a very large scale. Circularity is very much location-based. So the materials do not have to travel across the globe in order to be circular. Materials can be reused and lowering their embedded carbon within close communities. So this is what is this material bank being developed by CoCircular is doing. We also have a toolbox for circular construction assessment and integration, which is a very useful toolbox for the designers of circular renovation projects. And also the scanning of building elements by both TUS and the ARC, who can understand from scanning the building what sort of materials are available to reuse. So after this step, when we know what kind of materials we have, we move on to the robotic recycling, which is using old ceramic tiles and is bringing them into new implementation, like floor tiles. You have seen mosaic approach. So imagine a robot building mosaic tiles from reused old ceramic tiles. And then we have one more ambitious solution. So we have actually been collecting excavated material from the one project on one location in our demo sites, and we are assessing this excavated material and the demolition material. We are processing it and we are bringing it to a close construction point where the new component will be fabricated by robotic 3D printing. So this is how we are trying to close the loop between demolition and reconstruction. So these are our data-driven solutions in a nutshell. I will stay a little bit more on what digital twins in the DECO context can do for us. So the idea with digital twinning in DECO 2 is to make more meaningful choices, to know what we have available at the moment and decide what is the optimized scenario in terms of design choices, material choices, and also how to integrate better the digital product passports that we have available. So on the one hand, we have a line of the manufacturer who provide the list of the materials that are available. These materials are being tracked by DPP, and these digital product passports are provided to the designers in order to make the optimized, informed choices through the DECO 2 digital twin. So on a physical layer, you can see how on the bottom blue space on the screen, you can see that from our Castellón library, which is being torn down, we are breaking the materials, we're taking the materials, we are characterizing the materials through scanning, and we log them into the material digital product passports. Then these products are being reprocessed and remanufactured and get back into the building loop as a new product, as a panel, as a mosaic floor, or as a new product entirely. So this get back into the Valencia Living Lab in the UPC campus. So this is how the digital and physical loops close. And this can be, the idea is to select the optimal option before the renovation and also being able to monitor the decision after the renovation. So in regards to digital product passport, we know that this is going to be a reality soon. And I think you can scan the QR code to test our preliminary edition of the digital product passport. So this is available for testing as we speak. So I would urge you to do so. Let me know if this works for you.
Yeah, the link works.
Perfect.
So
That's great. So here we have a couple of already monitored value chains recorded on the distributed ledger. So we, through smart contracts, we are recording the flow and the CO2 and all the steps from production to reuse. And this is what all these steps follow. The steps that the material is taking is being recorded by the actors on the distributed ledger of our material passport solution. So you will be able to monitor this and keep an eye on this, because it's going to be populated with new materials, and we urge you to become part of this process if you wish. So our future plans. So we have ongoing activities in finalizing our decarbonization framework and making it dynamic, meaning that we're building our digital twins based on our decarbonization methodology, which is currently finished. So we're finalizing our DECO2 framework technical specifications, since we are on our 17th month of our project. And we are starting to build our virtual demos through the built-in digital twins. And soon we will be continuing with our exploitation activities, which have been initiated. And we're trying to put these solutions to bring them closer to the market. So in 2026, we will probably have the dynamic decarbonization scenarios digitalization, and the identification of barriers for digitalization. If you scan this QR code now, I would urge you to complete this form, because I think this is a binding element across all our projects. So what is stopping us from digitalizing construction? What data is nice, it's useful, it helps us a lot, but what is delaying us in bringing digitalization closer to the construction market, which is one of the laggards in adopting new technologies? So through this research, we're trying to understand better the requirements of all the stakeholder ecosystem in construction, and see how we can overcome this. Because DECO2 also focuses in policy, in standardization activities, and we can use this platform as a way forward to bring digitalization closer to construction across all the professions in architecture, engineering, and construction companies. Our future integration activities include the C toolbox, the material passports finalization, and also to see our first circular robotic construction outcomes. Of course, we're starting with the optimization services and the integration processes of these technologies, which is going to be quite demanding. And of course, at the same time, as I explained earlier, we will put a lot of effort in the certification and the standardization activities which are quite challenging for secondary material, as we all know. So I think that's it on my
thank you,
side.
Lenny. So actually now we're almost right on time. It's time for our Q&A session. I suggest I pull up again the barcode that Eleni had in case you want to scan it and complete the form. I don't know if, let me check if there are any questions online yet. I don't see anything. So, yeah, I mean, this is, a time for questions from the audience. Please.
Thank you for the presentation. It was very interesting, at least for me personally. So just very briefly, my name is Vatana, and I'm from University of Côte d'Azur in Nice, in France. And I'm representing INBLANC project. And just very briefly, my project works on producing 10 innovative products which compromise, recycle, reuse materials. And when the majority of the projects here present, like Wilson, INBLANC, RECONMATIC, and DATAWiSE, I can see so many possibilities where we could work together. My inbuilt, my project, they could fit into your technology and your processing. But I can't wait to connect with you more during lunchtime.
Absolutely.
But just very quick question I'm sorry, Anna, very
Eleni.
last one. Yeah, Eleni, right. I'm very curious to see when you mentioned about the community oriented, like how can the data collected benefit the people? Right, that's the most important part. Can you elaborate a little bit more? How exactly do you plan to do that? Because on the technical part, it's easy. We talk, we understand each other. But when you talk to real people, like citizens, how do you convince them? How do they take part in redesigning and everything?
Thank you very much for the question. It is a very good opportunity to talk about the work by University of Graz, which has been working with the actual the collaborative how to call it, association of the inhabitants of Terrassen House in Graz. So they have set a very committed group of inhabitants of apartment owners there, and they are carrying out frequent workshops explaining explaining and co-designing how they can contribute towards building meaningful products for circular renovation. So for people, distributed ledger technology doesn't mean anything, but when they get the chance to explore how a material is being tracked and how its value in regards to CO2 footprint is growing or being reduced as it's being reused again. So this approach, the information approach, and their contribution in design choices that they see through the workshops, the co-design workshops that they are carrying out there, their contribution towards deciding and having the actual tools to choose which material they want to bring into their homes is really important, because it gives access to the people to informed decision making. This is what actually data-driven solutions are focusing on doing. So this is when you give access to people and they explain the technologies to them, then technology is meaningful, not only when only architects discuss about it, not only when researchers are discussing about it. So it is meaningful to provide the tools on how the contributors and how the people who are experiencing the results of this technology can contribute to this. Actually, the title of the workshops was Wie kann ich? How can I? With a big question mark. How can I be part of this decarbonization pathway? How my decisions influence the carbon footprint of my own building. So I think we will have an idea soon about how the outcome of the workshops are going. and we will have the chance to document this on our distributed ledger technology. Thanks.
Thank you. Thanks so much. Any other questions? Still have 2 minutes left. So
Not a question, just a request.
Yeah.
I'm a brand ambassador for an Italian manufacturing company that is dealing with modular buildings. So I would like, if it's possible, to embed internally already in this manufacturing, in briefly, our stainless steel structural wall that can embed inside the electrical plant and the plumbing. Would be great even to integrate and add some sensor that then can bring all the data of the building already to your application. So this is something that is possible. Can I
I'm
have
not
some
sure if
financial
there is already
control?
an existing solution for this.
Excuse me?
Is there any existing solution for this or something that comes close to what you are requesting on the market right now?
Yeah, I
There
think
is?
so, but just because I'm not a technician, but I would like to bring some more detail to the internal, let's say, department, production department, because right now is anti-seismic, it's just laid down on the pavement without, so can easily move and rearrange a building in order to keep it, let's say, reliable and for sure a longer cycle. And when you have to maybe change the destination use of that building, you don't have to destroy nothing. Just you can rearrange the one system. That's why it's going in that direction, not to create waste.
True. And this also connects, like if there are any advanced artificial intelligence software that can analyze the BIM models and enrich the information with structural data on the building, then this, what you're suggesting could be quite possible, because at the same time, like you want the process to be very safe for the building itself. So yeah, BIM modeling, I think, is the solution.
Okay.
That's
Yeah,
noted.
BIM, we are already working in BIM.
Yeah.
Okay.
Thank you.
But if I may, as far as I know that, and we have tested that those large language models that seem appear to know everything, they cannot actually at the moment work with BIM data or, well, in some limited way. And this is something we are developing at the moment in a different project, structurally aware models, a model that could understand IFC. There is some pre-processing needed to communicate with the users. So imagine you can design a building by giving prompts. This is not possible at the moment because IFC is very complicated step format stuff, which is not very legible for computers.
Yeah, actually, that would make it quite user-friendly, you know, for the audience to work. And from what I've seen so far, general language models, like large language models, like ChatGPT, are not great at, you know, specific tasks. They have a holistic understanding, let's say, of things. So yeah, fine-tuned LLMs could very well be the answer to that. Okay, we're 2 minutes past, so I want to thank everyone for attending. I hope you had a good experience here. Feel free to connect with us either during the break or later on at the social dinner if you're attending. And yeah, thank you so much.